Hello and welcome back to Bite-Sized Neo4j for Data Scientists. This is part 13 in our series, and today we're going to talk about calculating centrality, so node centrality, which kind of gives you a hint at the importance of a node. My name is Claire Sullivan. I'm a data science advocate at Neo4j, and here's how to find me on the internet. Let's start by reminding everybody of the links. The first one is how to create a free Neo4j sandbox database instance. The second is where you can find all the videos in this series. And the third is the repository where you can find all the code. Let's start by talking about some theory around centrality. The first one we're going to look at is PageRank. This was, made famous by Larry Page at Google. It was the foundation of the search engine. And this looks at the importance of nodes, web pages in their cases, based on the links to them. So for instance, you see the yellow node, and that node is very big, indicating a large page rank because a lot of other nodes are pointing at it. Then I have the green nodes who they point at some things and nobody points at them, so their page rank is pretty small. But that node in the upper right, that red one, has a pretty big page rank, not because it's got a lot of nodes pointing at it, but because the yellow one is pointing at it, that really important node. So that's how we get page rank. Next, we're going to talk about betweenness centrality. And the way I like to explain this is the bridge nodes. This is the one who's going to introduce you to the other ones. So think about you want to have a meeting with the big boss person. Now you could go talk to all of your friends and see if you could get that meeting set up. But the more efficient way to do that is to find the admin, the person who is the link to the big boss person. So if the big boss person is red here, that green node is the one that everybody talks to because that green node is the one way into the red node. Now using this same figure, we can also talk about degree centrality. And what degree centrality is just how many nodes point at you. So for instance, that red node at the bottom has a whole bunch of nodes pointing at it. So it's got a high degree centrality. All right, cool. Let's get into doing some code. Okay, I've got the Game of Thrones graph loaded up here. And we're going to start like we do with all things in the Graph Data Science library by creating an in-memory graph. I'm using native projection to do that in this case, like I showed in part 12 of the series. So we're creating an undirected graph looking at the interaction relationships between people. Okay, so there's our graph. Cool. All right, now let's calculate the page rank based on this graph. Okay, so all we do is we call this page rank. We use stream, which means I just want to output it to the screen. And then you recall that GDS uses this mapping into a node ID space. It doesn't correspond to anything we'd recognize. So we use this function here as node to bring out the name of those nodes and their score. And we'll do the top 10 here based on score. And if you know the books, this makes sense. Jon Snow is a pretty important character. Tyrion Lannister, pretty important. Okay, cool. But let's look at the GDS docs, and let's specifically look at PageRank. And what we see here is that PageRank can work for directed and undirected, but it can work for weighted graphs. And that's really cool. So let's actually run a weighted graph. Now this time, just for giggles, just for some variety, I'm going to use the cipher projection. And in that projection, actually, I should have shown that again. Let me just put it back up here. I am bringing in this projection here, people interacting with other people, but I'm returning the weight of that relationship here. So that's how I'm creating a weighted graph. Okay, so now let's run PageRank on the weighted graph, and we would expect to see some slightly different results. Okay, let's see what we get. Okay, now I get that Tyrion Lannister has the highest page rank when I use the weighted graph. So things have changed here. I'm kind of surprised with some of the names down here, so you might want to give that a think over. Okay, next one we're going to do is betweenness centrality. Okay, let's look at betweenness centrality right here. Now you see it does not work for weighted graphs, so we're going to have to do that on the unweighted in-memory graph. Let's give that a run. Remember, these are those bridge nodes. Okay, like the admin in your office. Okay, Jon Snow, Tyrion Lannister, Daenerys Targaryen, very cool. And lastly, let's look at degree centrality. Okay, and you'll note that degree centrality can work on a weighted graph. One thing I want to point out here before I forget is all of these required homogeneous graphs. Why? Well, because it doesn't make any sense to try and say, okay, well, which is the most important node in people and battles? Okay, battles aren't people. So we want to make sure that all of our nodes have the same type when we run these centrality calculations. Otherwise, the results are pretty meaningless. Okay, here's our degree centrality. Let's see what we get here. And I see that Cersei Lannister has the highest degree centrality. So that's interesting. So give a thought as you're looking at your different centrality calculations as which one applies most to your problem. And try a few. Don't feel like you have to be limited to just one of them to make a decision. Thank you again for tuning in. Please reach out if you have things that you'd like to see in future videos, and we'll talk to you later. Thanks.